Skill 5.4. Interpret the evidence for the existence of the particles in matter by observing daily life examples. S. Interpretation. SS. Analysis, critical thinking. Objective. To help students interpret the evidence for the existence of particles in matter by observing common and real-life examples. Instructions. Scan the given QR code to access worksheet. When you have understand the particles as building blocks of matter, you should be able to interpret the existence of particles in matter and solve it. Knowledge 5.2. States of matter and particle theory. Here we will discuss the reasons for the behaviors of each state of matter using particle theory. 1. Solid. A solid has a fixed shape and volume because the particles in a solid remain closest to each other. The strong attractive forces bind them together. Solids cannot flow because their particles cannot slide past each other. They only vibrate in their positions. Solids cannot be compressed because the particles in solids have little space between them. Figure 5.1 Particles in solids. 2. Liquid. Liquids do not have a fixed shape because the particles in liquids do not have a regular arrangement. The attractive forces among their particles are too weak to give them a shape. Liquids have fixed volumes because the forces among the particles of liquids are strong enough to hold them together. Liquids can flow. This is due to the loose arrangement of particles, due to which particles move freely and slide past each other. Figure 5.1 Particle model of liquid. 3. Gas. Gases neither have fixed shape nor fixed volume. The reason is attractive forces in gas particles are too weak to bind them together. They move freely and do not touch each other. Moreover, they may leave out the gas if not enclosed in a vessel. Gases can be compressed because particles in gas have large spaces among them. Due to the large spaces and free movements of particles, gases can flow. Knowledge 5.3. Changes in states of matter and particle theory. We have learned that temperature affects the motion of particles. When this motion increases or decreases beyond a certain limit, matter changes into another state. The processes that explain changes are given below. 1. Melting and freezing. Bring out ice cubes from the freezer and keep them at room temperature. Soon, these cubes start melting and change into a liquid state. The room temperature is greater than that of the freezer. Due to this, the particles of ice begin to move fast. Upon continuous exposure to high temperatures, the movement of particles of ice becomes so fast that they begin to flow over each other, and the ice melts. The temperature at which a solid changes into its liquid state is called its melting point. Ice begins to melt when its temperature increases above 0 degrees Celsius. Similarly, if water is cooled below 0 degrees Celsius, its particles release energy. The movement of particles becomes slow, and they come close to each other and start to freeze. The temperature at which a liquid freezes is called its freezing point. Figure 5.2 Effect of heat on arrangement of particles during melting and freezing. 2. Boiling. Upon heating, the particles of the liquid move rapidly. Fast-moving particles leave the surface of the liquid quickly and change into gas. The process by which a liquid turns into a gas with the action of heat is called boiling. The temperature at which a liquid starts to change into gas is called its boiling point. The change in the state during boiling is given below. Heating. Liquid gas.